And we are live. Welcome everyone in to today's webinar. We are just going to give it a few minutes so folks can make their way in. But really excited that you've joined us on this Tuesday for a presentation on SPDX. So if you're just joining us, thanks again for being here. We will start in approximately 1 minute. So yeah, if you could just hang tight with us for another handful of seconds here, we'll get started soon. In the meantime, Gary, happy Tuesday.
Hello. Happy Tuesday to you too.
Thank you. Thank you. We're just going to give it another 30 or so seconds so everyone can make their way into the webinar. And then we will get started shortly. So if you're just joining us, thanks so much for being here. We're just giving it another few seconds so that everyone can make their way in. We will get underway soon. All right, almost ready to start. And I guess let's go ahead and kick things off. So, first of all, again, just really excited that you're here with us today for this webinar on the SPDX software bill of materials specification with Gary O'Neill, who is the co-lead of the SPDX tech team. My name is Andy Drukarev from FOSSA, and I'll be your host for today's discussion. Before I go over our agenda and turn things over to Gary, I want to go over just a few quick housekeeping points. First, we will do our best to answer any questions you may have as they're submitted. If we can't get to them, we'll also have time at the end for a Q&A. Please do feel free to post any questions you have in the questions section of your BrightTalk console. Next, this webinar is being recorded and will be sent out to you after the event. Finally, we at FOSSA will be following up with you after the webinar with a few additional resources and to see if there's anything we can do to help your organization manage SBOMs. Now, this is a very quick look at our agenda for today. There will be more details than this, as you'll see as we go through the presentation. But quite broadly, the first part of our webinar will cover some important context around SPDX, what it is, why it's important, its history, and an SPDX document structure. We'll then shift to a discussion of the best ways to generate SPDX SBOMs, and then tips for using SPDX to support security and license compliance initiatives. Finally, we'll conclude with a preview of what to expect with the next version of the spec, SPDX 3.0 and beyond. Now, before I hand things over to Gary, just a few words for everyone here who is not familiar with FOSSA. We provide technology that makes it much easier and more efficient for organizations to manage the open source software that you use. This includes identifying and remediating open source vulnerabilities, as well as identifying and complying with licenses in open source code. Additionally, because the foundation of FOSSA is really our ability to quickly identify and inventory the components in your software, we offer a comprehensive SBOM solution. You can use FOSSA to inventory your open source and generate and manage SBOMs in a range of formats, including SPDX. So with that, super excited to turn things over to you, Gary. Wondering if you could share maybe a bit about your background and work with SPDX before kicking this off.
Greetings. Yeah, thank you. So I'm Gary O'Neill. I run a small consulting business doing source code audits. That's where SBOMs comes in for me personally. But more importantly, I've been a co-lead of the tech team on SPDX almost from the very beginning. So spent quite a bit of time, with that organization. It's a member of, it's a project under the Linux Foundation, but it's actually just really a collaboration from a number of volunteers like myself to promote a standard for software bill of materials. In this talk, I'll be talking about my favorite subject, SPDX. I think at the end of the talk, you'll have a much better feeling for, what the SPDX standard is, how to read them, how to use them, how to generate them, and perhaps a little bit of the history. And at the end of the talk, I will be going into a little bit about what to expect in 3.0 and some of the next releases on there. So let's start off a little bit of context. What is an SBOM? A software bill of materials. It's basically just the ingredients that you have within your software. This slide here is from the NTIA and CISA, U.S. government agencies that have been really promoting SBOMs rather recently, and including them in some of the upcoming government regulations. But I think it's a very good description of what an SBOM is. It includes relationships of the components, what the components are, and they could be anything, whether it's open source or proprietary software. Basically, again, what are the ingredients that in there? So in terms of SBOMs, oops, I got to click on that. Sorry. Why are SBOMs important in general? The one that's getting the most press these days is security vulnerabilities. There's been a few very public supply chain attacks that have been somewhat painful for the organizations involved. If they would have had an SPDX document, the consumers of the software, they would have known that they had vulnerable software and could have taken some protection. So it's actually quite an important area to secure your software. Similarly, license compliance. This is where SPDX actually got its start, is in license compliance. If you're going to comply with your open source licenses, you better know what's in there. Again, leading back to SBOMs. Something that's not really talked about as much, but I think is equally important, is the maintainability of the software. If you can identify the open source software that's dependencies of software that you're using, there's a lot of tools out there that you can go in and explore how maintainable that open source software is. You can basically get grading on what that software is. And finally, government policy. I have to admit, I think this is what's driving a lot of the SBOM adoption these days, is new regulations coming out from the EU and the US federal government, requiring that SBOMs be used in certain scenarios. So it's getting a lot of attention lately, and keeping us very busy in the SPDX community. So let's talk a little bit about SPDX and its history. I'm not going to go through all these bullets, but I just want to hit a few highlights. First one is we've been around for a while, since 2010, when we created the first specification. We had a big increase in the scope of SPDX in release 2.0 in 2015. We actually created 38 different use cases that were contributed from a lot of different organizations. And one thing I do want to mention about SPDX as an organization, we're an all-volunteer group, but it actually involves, we're very inclusive in terms of participants, in terms of organizations, in terms of different usages. So anybody who has a need, a problem that needs to be solved, where having your bill of materials can solve that. We welcome those use cases in. It does come at a bit of a cost, though, in that it takes a little longer sometimes to get consensus when you get a lot of people contributing, from perhaps not solving the exact same problems as some of the other participants. And it can lead to, a little bit more complexity in the standard. But I'll hold the thought on complexity, because we've got some things coming in 3.0 that I think will help address that quite a bit. The last milestone I just want to mention is in 2021, we actually achieved ISO certification. So we're now a formal standard, a de jure standard, not just a de facto standard for SBOMs. That's important for some organizations that want to make sure that it is a true standard for SBOMs. I have heard a little bit of criticism that that makes SPDX a paid standard, and I just want to make it really clear that is not true. So if you heard that you have to pay for SPDX because it's a standard, be sure to point them over to the SPDX website. It's always been free, always will be free. And in fact, you can get a free version of SPDX on the ISO website if you know how to navigate through some of their pages. So that's a little bit of the history of SPDX. Let's talk a little bit about what actually SPDX is. A lot of people know about SPDX from the different formats. We have a lot of different file formats in SPDX, everything ranging from JSON, which is my personal favorite, all the way over to spreadsheets. I mean, a lot of people don't know that we support spreadsheet as one of our input and output formats for SBOMs. But you'd be surprised how popular these spreadsheets are, especially with lawyers. Lawyers seem to love having spreadsheets. But we support a number of other formats too. RDF, tag value, YAML. Now, you may be asking, okay, there's all these different formats. Doesn't that make things really complicated to validate? And it turns out that all of these different formats are driven from a common model. And we do use a combination of formal UML modeling, object modeling, and also we use RDF ontologies that are formally defined as well. And by having this kind of common model that's used by all the different standards, we're able to validate all of them and actually be able to translate between them as well. The reason we support all these standards, again, you know, we try to meet the needs of a large community of people that are using SBOMs. Some really want JSON, some really want spreadsheets, some really want something simpler like tag value. So we do try to accommodate them all. And we have an excellent team of volunteers that helps with the tooling and specifications for all of those. Oops, I think I might have missed a slide there. Now let's dive in a little bit into what these different formats actually look like when you look into them. In SPDX2, there is all the information is contained within an SPDX document. An SPDX document is what contains the SBOM information. If you are asking for an SBOM, from a provider of your software, they'll give you an SPDX document that contains it. So when you look inside the SPDX document, it contains some different information. It contains the document creation information, who created the document, when was it created, information about the packages, the components of the SBOM itself, and optionally, it'll contain information about the files that actually make up the packages. And then you need to know what the relationships are between the packages, if they're dependencies or packages in the files, or even a relationship between the document and the packages themselves. And I'll give you some very specific examples of what that looks like in a minute or two. Now let's talk about the fields that are present. And to create a basic SBOM, there really isn't that many fields you need to worry about, but there are a few very, very important fields. So this is actually the NTIA minimum SBOMs that's defined by a working group working with both CISA and NTIA. And I'll just run through these fairly quickly. The supplier, it's important to know who supplied the software component to you, the name, of course, the version of the component, because, security vulnerabilities that are present in one version may not be present in another. And then this is really important, the other unique identifiers. We have a little bit of a problem in the software industry, and that there's no universal package code. There's no one naming convention that we have to be able to uniquely identify every software package. There happens to be many of them, actually, especially in the open source world. So these other unique identifiers are a way to capture those. So a really popular one these days is package URLs or PURLs. There's also many others like software heritage IDs. There's also other ones that are generated from Merkle tree hashes. And there's a lot of different choices. We encourage people to put in as many unique identifiers as they can, and you'll see why in a few minutes when I get to the security use cases. Another part of the minimum SBOMs is the dependency relationships, and then information about the SBOM itself, who created it and when was it actually created. So those are the minimums. Now, we actually recommend a few additional fields beyond the NTIA minimum. One is some method of verifying the component, like a hash of the file that you got. The download location. If you download it, if it's publicly available on the internet, it's kind of nice to have the URL where it was actually downloaded from. In fact, that URL can actually be kind of handy as an identifier for the package as well. And then license information, how was it licensed? That's all useful information that we recommend adding to it. So now let's actually dive in and look at an actual JSON file so I could show you what this looks like even more detail. So I'm going to share my screen and entire screen.
And while you're doing that,
Sure.
thank you for, we do have one question, but it has to do with SPDX3.
Sure.
I think we'll save part of it for the discussion on SPDX3, but in the meantime, there is a question on your feeling about tag value,
Oh,
um, and how that will carry over to SPDX3, and would it be better to concentrate, e.g., like on JSON, and then rely on tools to do the conversions?
oh yes. Oh man. I was just in an SPDX call this morning where this was a topic of let's say intense discussion. There is definitely a community that really would like to see something simple, like tag value. Since the question was, what do I think? I'll give you my personal opinion, but it doesn't represent the entire community because you'll see a wide range of opinions on it. I actually think tag value plays an important role for a very specific set of use cases. If you're responsible for maintaining an open source package and you want the simplest way to represent an SBOM, tag value may be a lot easier to do than doing, for example, on the other extreme, an RDF representation of the package. So I think it has its place, but I don't think we want to constrain the SPDX model by what can be represented in a relatively simple form as tag value. So my personal opinion is it has its place, but it's probably going to be a subset of SPDX. And yes, tooling plays a really big role in being able to convert between the two, between the actually several different formats. Good question, very topical, actually, top of mind for me. So let me,
Sorry to
yeah, go ahead.
interrupt. One more to get in here.
Sure.
Uh, can I extend SPDX to add additional fields based on an organization's needs, keeping the schema intact?
Yes, we in SPDX2 we have annotations that are very specifically there so that you can take any element of SPDX and add to it. In SPDX3, we're going to take it a bit further with extensions that actually provide a little bit more structured way of adding this. And just to give you an idea on the annotations, I've written some conversion tools from other SBOM formats, and where things don't fit into SPDX, I just add them in as annotations. And that's a good way to extend it. Good question. Okay, so let me just give you, I know this is a bit of detail, so I'm just going to go through this fairly quickly, but main thing I want to get across in this example is that, there isn't that much to a minimum SBOM. It really isn't that hard to produce, and I think all the fields are pretty understandable. So this is a valid SPDX document. It's in JSON format, my favorite. See it start off, there's an ID for the document itself. It's always SPDX document. The version for the spec is pretty important because some fields are supported in later versions, but not in earlier ones. And then here's your creation information for that minimum SBOM element of when was it created and who, what, or could be an organization, a person, or a tool that actually created it. So you can put all of those in here as the creators of the document. And then we have a name, whatever name you want to choose, a data license for the document. And this is kind of important. This document namespace, it's just a unique identifier. And the way I created it is I put it in kind of as a URL syntax with the name of the tool and the version. And then I just generated this unique ID using an online tool for globally unique ID generation. But this has to be unique. And the reason for that is it gives us a way to refer between SPDX documents. So if I want, in one SPDX document, I want to refer to another, you want to make sure that it is the document that's being referred to. So that's why we have this document namespace. Then we get down to the description of the packages itself. It's got its own ID. It's got the name of the package, the version, the organization. And then this here is the optional information, not required by the NTIA minimum, but we recommend it. This package file and checksum is just your way of verifying that the package described in this SPDX document is the one that you actually are looking at. And then we have the download location as well. Now these external refs down here, this is the other identifiers. And in this case, I'm just using an example, the package URLs. So it has a category. It tells you, this tells us that it's a Perl or a package URL. And this is the actual package URL string. So this is how we do the external identifiers or the other identifiers. And then this file analyze, all that does is says that there's no files, we didn't analyze any files that are associated with this package. And this last section I'll just mention is the relationship. Since this is a very basic SBOM, the only relationship we have is between the SPDX document and the package. And basically what this is saying is that this SPDX document itself is describing this package. It just gives you kind of the root of the tree of package dependencies, kind of where to start, what this is actually describing. Now that we have this document, I just wanted to show you a couple of things, that we can do with it. There is actually a way to validate the tools online. This is just at tools.spdx.org. And if you want to make sure that it's valid, we can actually take, this thing that we just looked at, this minimum SBOM, drop it in there, and I gotta tell it it's a JSON file. Then we validate it, and it comes back and says it's valid. But what about the NTIA minimums? There's an NTIA minimum conformance checker, which will look for those very specific fields that the NTIA expects. You can drop it into that and check that, and it also comes back and tell you it's valid. So those tools are available to you. By the way, if you're this is also available as a command line tool that you could download. It's all open source. We welcome contributions, by the way. So that's the tool. Let me see if I can find a way to navigate back to, what I'm going to do? I think I'm just going to share the slides to make it a little bit easier. So that's the SPDX document. That's pretty much all there is to it. For the minimum anyway, I bring this up full screen. Are you able to see that okay?
Yeah, the slide.
Okay, good. Just wanted to make sure that was coming through okay. So now let's talk a little bit about how you actually build or generate, these actual SBOMs if you're a producer. So the one thing I'd encourage is that this is actually done during the build of the software itself. The build process knows the most about the software. It knows about the software coming in. It knows what artifacts are being produced going out. So it's in a very unique position. And there are a few tools out there that can generate these SPDX documents. A lot of them are available on the SPDX GitHub repo. I'll have links for those later on in the presentations. But for example, we have a Maven plugin, a Gradle plugin. There's an SBOM generator for GitHub Actions. And of course, the FOSSA software also produces SPDX documents. So that's another good choice for being able to produce the SPDX documents. But a lot of times people run into situations where they don't have access to the build environment. You're getting software delivered to you. So you need to be able to do generation of the SBOMs through some type of analysis. So on the analysis tool, I kind of break them into three different categories. There's analyzers that work off of the build metadata. So these would be like the Gradle files or the POM files or the package files that describe the dependencies. There's source license scanners that'll scan through source code and pick up licensing information. And then the source snippet scanners, which actually works with some gigantic database of small little source code snippets. And they try to correlate where did this actual code snippet come from. The one thing I will mention on the source snippet scanner is that they tend to generate a tremendous number of false positives. And I always encourage people, if they want to go on the route of snippet scanners, to make sure that they're planning on having humans in the loop to be able to kind of detangle the amount of false positives in there. I mean, I run across this when people are doing corporate acquisitions. I don't run across very many snippet scanners that are used in actual build environments. So, but that is an option out there for you. In terms of the SPDX generation, one thing I just want to mention is there's really kind of two different types of SPDX files that you can generate from this type of analysis and from the build system. There is information about the source files that includes the snippets, the code, the licenses that are in the code, and then information about the dependencies are there. And I really would encourage people to look at both of these sources. Dependencies are important for understanding not only the security vulnerabilities, but also, any license compliance supportability issues. But the source is also very important, especially in license compliance, knowing, all the source files that are there, because sometimes you'll run across licenses that are a little bit unexpected. So for a complete picture, we always advise to have both that information in there. So now let's take a look at what, having this information in the SPDX document, what that actually does to our SBOM. So when we add source in, basically a couple of things happen. First, you'll see this new section called files, and it's pretty simple. They have each file has its own ID. There's a file name, and then we do a checksum for validation that's on there. Within the package itself, this files analyzed is now set to true. And then we have this extra little field here, which is the package verification code. And all that is a checksum of the checksums of the files. And it's just a quick, handy way of being able to make sure that the files that are claimed to be part of the package really are. It's just an extra level of verification if that's needed. And then there's one additional relationship. Since we're talking about source files that belong to the package, we have this relationship where the package contains this SPDX file. And that's it. That's how you would represent source files within the SBOM. Now, switching over to dependencies, if we wanted to add dependency information within the same package, basically we just add another package in there, just like we did for the package that's described by the document. This will be a package that's a dependency. Now, I want to make sure you understand this is just a demonstration. I'm using as an example my own, one of the tools that I maintain. It really does not have this dependency, and you'll understand why it's important to know that when you see the security demonstration. This really is not part of the tools. I really don't have this vulnerability that you'll see in a minute. But this extra package has a lot of the same information. It has a package URL, very much the same. And then again, we add one more relationship here, which is this SPDX package is dynamically linked to this document. Now, let me show you what you can do with this additional information that's there, especially as it relates to security. And what I have is just, if I, didn't have this quite ready yet. I have this little utility. This is another open source utility available from the SPDX GitHub repo. It's called SPDX to OSV. And basically what it does is it reads in the SPDX document, goes out and queries a online vulnerability database that's free of charge, free to access. It's called OSV. I believe it's maintained by Google. And it'll generate an output file of basically what it finds. So if I run this, and you can see by the warnings and how long it's taking, it really is working. And then if I type the JSON, see what it says. And lo and behold, we're finding all kinds of interesting vulnerabilities for that dependencies. That's, again, just for demonstration purposes. So that's just how you would use that in kind of a security scenario. Switching back to the presentation.
And Gary, while you're switching back, maybe we can get in another question.
Sure.
Are there any tools which can read SPDX and draw the dependency graph? Hopefully, SDA tools available on the market can do that. And I will give kind of the FOSSA answer to this, but we'll let you take the first stab at it.
Sure. No, there's one that I really like, an open source tools. You'll find I reference most of the tools I reference are typically open source, and I'll definitely give you a chance to answer the FOSSA question as well. But the GAUC, G-U-A-C, or this G-A-U-C, GAUC, is an open source package that actually will do a full dependency graph based on ingesting SPDX data. It'll actually correlate it with many other sources of information and give you some really interesting data. So GAUC is one I would definitely check out. But go ahead on, if you don't mind adding the FOSSA specifics.
Yeah, so this is something we're actively working on. I would encourage whoever asked that question, like I said in the intro, keep an eye out for an email from FOSSA, and we would love to set up some time for you to talk with our product team and provide more technical details there.
Yep. And if we got time at the end, I'll see if I can get you a URL for Guac as well. It's in development, so it's not a polished commercial product like FOSSA is, but it's interesting. I think you'd find it interesting. So let's talk a little bit about how you use SPDX a bit more. I showed you a little bit on security. The key thing on the security is those external references. The more you have, the more information, the better chance you have of correlating it with the vulnerability database. Now, there's kind of a raging debate right now within the SBOM community about what do we do with this security information, and how much of that information is stored in the SPDX document, and how much of it is just saved externally. The reason for the debate is SBOMs are typically fairly static. It's produced at build time. It's not updated very, very regularly, but you'll find vulnerabilities all the time. And so you might learn new vulnerabilities, or maybe a vulnerability is resolved or determined not to affect a piece of software. So, what I believe is you should be storing the external references in the SPDX document and using external third-party databases to find the vulnerability so that they're always up to date. But what if you're in the category of people that think that the SBOM should be sharing the security information? For that, I'll give you another quick demo of what that looks like in a real SPDX document. It's actually pretty straightforward. This is the package that had the vulnerability we just discovered. And this is the URL to the CVE, the advisory about this specific vulnerability that we pulled out of OSV. And so you basically put in another external reference. This time it's got a category of security. That means it's some type of information about security. And the reference type is that it's an advisory, and then the very specific URL is basically how it's communicated. Now, in SPDX 3, we're actually expanding this quite a bit. We're actually putting in the fields for some of the security-related information directly, because there is, like I said, it's a raging debate. There's a large community that really would like to have that information in the SBOM itself. So we're actually accommodating more of those use cases. Some more of those use cases going forward. So that's what security looks like. Licensing, the other big driver for SBOMs. In terms of licensing, SPDX has a few fields, copyright fields and licenses for the components and files, even down to snippets have licenses associated with it. One thing I'll mention on licensing is we split licensing into really two different fields. There's the declared license, and this is the license that's actually found in the file. It could be an SPDX license ID, it could be license text, but it's what's actually detected or declared by the package itself. And then there is a concluded license. Now, the concluded license involves some type of analysis, mostly human, sometimes machine, but the concluded license may actually disagree with the declared license. Now, why would that be? It may be because there's a copyleft license where the linkage actually influences the license of another stated license, or it could be a situation where there's a choice of licenses and the person supplying you the combined package that has the open source along with perhaps other licenses has made a choice, and they want to communicate that be in the concluded license. And quite honestly, sometimes the license information that's detected is just wrong. It may be that the origin of the software is someplace else with a different license entirely. So that gives us an option to do that. So if we take a look at what the license information looks like in the file, this would be my last detail slide. You'll see that both in the packages and in the files, you'll find a few additional fields. There's the license concluded, the license declared, and then in the package, we also have this field. If you analyze source files, we also include all the distinct licenses that we find within the files. So it gives you a handy way of finding that at that level. And of course, there's also the copyright text as well. for that. And you'll find similar information within the file, the copyright text license concluded, and the license info and files. That's the declared licenses for the files itself. So that's that's all there is to representing the source files within an SPDX document. So that's it. That's the usage of SPDX. I think what I want to do now is just talk a little bit about the future. We actually did our release candidate 1 release of the SPDX model a couple of weeks back. We're working on a release candidate 2, which will have some update based on the feedback we've received. And SPDX 3 is a fairly major upgrade to the SPDX specification. And these are some of the drivers and enhancements that you'll find in SPDX 3. First one is simplification. We've gotten feedback that if all I care about is security, I don't want to have to learn all this license stuff. Or if all I care about licenses, I don't want to know about all the security stuff. So we're introducing this concept of profiles. And so when the spec is released, you'll be able to go into our website, select the profile you're interested in, and only see the information for that profile. But we can also use the profiles for validation. Within a particular profile, say licensing, you may say that for that profile, the declared license is required, the concluded license is required. Whereas if you're doing the security profile, there's no need to be able, to have those same fields. So it's both for validation and for, readability of the spec. We were making some changes to make it a lot more flexible. I think the biggest change we're making is you no longer have to wrap everything around a document. And what this enables is if you want to make a database of SBOM elements available, over the internet, and you want to be updating those almost real time, you can set that up and comply with the SPDX specification. So you can go all the way down to the very individual file or even just the individual relationship and make that available. And the standard has all of the linkages in there and the verification information to make that work. So it's going to be a lot more flexible, especially for online data access. We're adding some very specific information about software, build and usage metadata for repeatable builds. And then AI, actually AI and data, I think is the most interesting one. There is so much going on in AI. And if you look at what's going on in the regulatory environment, there's like a crying need for information about what's going into these AI models, especially the data going into the AI models. So we have a sub-team of people that are deep into this area that are defining, properties and parts of the spec for AI and data. And then even beyond 3.0, we got a few work groups that have already started up. Safety standard automation. If you think about software that's being used in medical devices, you want to make sure that it's safe. So this actually goes beyond, the build and the security environment that we're doing in 3.0. And there's already quite a bit of work going on in this particular area. If you want a medical device to be safe with the software, you need to know what hardware it runs on and what is the configuration for the hardware. So we have some work going on in that area as well. And then one of the groups that I'm leading up is SPDX for services. And this is actually based on a CISA work group for service transparency. So we're basically taking the work that they've provided and making sure that if you're using a software as a service, that you can get basically a service bomb, of the information and be able to use that to know that you can trust the service provider that's in there. So that's the overview of SPDX. I would just ask all of you, start using SBOMs today. Ask for SBOMs from your supplier. Run it through the validator, make sure it's valid. And join an SBOM community. I mean, there's a lot of them out there. SPDX is a very welcoming community. We can always use more tools contributions, more spec contributions, and definitely welcome to join us. There's a list of additional references that are there for some of the tools and organizations that I mentioned. And lastly, just thank you and open it up for other questions.
Yeah, thanks so much, Gary, for that wonderful overview. Like Gary said, please do feel free to submit questions if you haven't already. We do have a few minutes. I think the first will just be going back to SPDX 3. What formats will be supported? Is that any changes there?
Well, it's currently under discussion. The two, I think there was a question earlier about tag value. That has not yet been decided. I'll tell you where we are in the 3.0 process right now. The model is pretty much done. It's under review, and we've got a few, like I said, a few updates on that. Once we have the model 100% done, then we're going to move our attention to the serialization. And first on the list is decide which serialization formats we'll be supporting. So I know JSON's going to be there. I know that RDF formats are going to be there. There's a question on whether we can make spreadsheets work for everything. Tag value is under debate right now. You heard my opinion on that earlier. I think with JSON being there, YAML's very straightforward, so that'll be there as well. And XML, there's definitely enough of a community on XML. But I'll tell you again, for those of you, interested in this, join our community. If there's a format that you like, really, we're limited by bandwidth. So if you're passionate about making tag value available, join the community and help us make it happen.
I think one sort of related question that comes to mind for me is if you have any guidance around which SPDX format might be best for which use case. And I know that's sort of probably an impossible question to answer because obviously different organizations are going to operate differently. But any sort of broad strokes, hey, we've seen this format work better for this or anything along those lines?
Well, I definitely have my favorite format, which is JSON. I would say, if you don't mind a little extra data in your JSON file, JSON LD, JSON linked data, gives you everything that the model supports. All the other JSON LD and RDF, everything that's in the model is losslessly provided to you if you use either of those two formats. If you go with any of the other serialization formats, you lose a little bit of information. Now, most people don't care about the information that's lost. So I think JSON is going to be, I would predict JSON is going to be the most popular format. But JSON LD I would encourage people to look at that. And it is a little bit more complicated, a little bit more verbose. But if you can tolerate that, it'll give you all the information you need.
Got it. Well, I will give it another few seconds for questions because what usually happens is I end the presentation and then I realize that 3 questions came in right at the finish line. But if not, then I think we can call it. And just want to give Gary another huge thank you for your insight here. This was a wonderful presentation. Again, thank you to everyone who took time out of your day to be here. And like I said, please do keep an eye out for email with more communication, and we will also be kind of putting together more SPDX related content and resources in the weeks ahead. So yeah, I guess with that, we can go ahead and call it. Thanks again, everyone, so much for being here, Gary, for your time and wonderful insights, and hope everyone has a wonderful rest of your Tuesday.
Great. Thank you, Andy. And thanks everybody for attending. Thanks.
Okay. Bye.
Bye.